Welcome to my YouTube channel IITian Chem class. So let's going to discuss about formula mass and molecular mass. For that you have to know about what is formula mass and what is molecular mass. So let's going to discuss about that. So today we are going to discuss about formula mass and molecular mass. Molecular mass. From that you have to know about the difference between what is formula mass and what is molecular mass. So let's going to discuss about the difference between that. So in formula mass, it is calculated by adding the mass of atoms present in the simplest formula that can be given for a molecule. Means when there is a molecular formula like C6H12O6, what is the norm of this compound is what is glucose, right? So in the molecular formula of glucose, first you need to convert this into the simplest formula. Like when you divide this 6 into the 6, then its simplest form is 6 by 6. Its simplest formula is what? CH2O. Then it is the simplest formula for the glucose. By only convert this into the simplest form, you can calculate the formula mass. Clear? But in the molecular formula, you have to calculate this C6H12O6 for glucose as it is. Clear? You don't need to convert this into the simplest unit. Difference is only that. Here you need to convert it into the simplest unit, but here you don't need to calculate this into the simplest unit. So what is the molecular mass of that molecules is 6 into 12 plus 12 into 1 plus 6 into 16. Okay? This is the mass of carbon, this is the atomic mass of hydrogen, and this is the atomic mass of oxygen. Okay? The technique is that. Calculation is same for both. So the second postulate is that it may or may not give the exact value of the molecule. It may or may not give the exact value because you have to convert it into the simplest unit. And where the molecular formula always gives the exact value of the molecule, because here the exact value is there in the molecules. No need to convert it into the simplest form. So 3 number is that calculated using the empirical formula. Here empirical formula means the simplest unit form of the molecules, which are already discussed before. And molecular mass is calculated using the molecular formula. Yeah? Okay. So moving into the next point. The fourth point is that formula mass is applicable only for ionic compound. Example, sodium chloride, potassium chloride, etc. But in case of molecular formula, except ionic compound, all molecules are applicable. Yeah? For the molecular formula, except ionic compound, all molecules are applicable. In the ionic compound, the compound is formed in between metal and non-metal. Here, sodium is the metal and chlorine is the non-metal. But in the covalent compound, compound is between the non-metals. Example, C6H12O6, CO2, H2O, etc. Here carbon is also non-metal, hydrogen is also non-metal, oxygen is also non-metal, hydrogen is also non-metal, and oxygen is also non-metal, like that. So in molecular formula, you need to calculate in the covalent compounds or other covalent compounds, but in the formula mass, you need to calculate only for ionic compounds. Make sure that. So now let's going to calculate about formula mass and molecular mass. For example, the formula mass of sodium chloride. For that you need to remember the mass of sodium and mass of chlorine. So what is the mass of sodium is 23 plus what is the mass of chlorine is 35.5, and the unit is atomic mass unit, simply U. Okay. So plus this 0.5, 5, 6, 7, 8 and 5, 58.5 U. And next is the molecular mass of the example C6H12O6. So what is the mass of carbon is 12, hydrogen is 1, oxygen is 16. So now calculate 6 into 12 plus 12 into 1 plus 6 into 16. 180 atomic mass unit, simply as U. Clear? So calculate the formula mass for potassium chloride and molecular mass for CH4 H2O. Homoc this. Okay? Done? So you all learn about the formula mass and molecular mass. So let's going to discuss about what is empirical formula and how can we convert this empirical formula into the molecular formula. Clear? So one question is that in a compound percent carbon equal to 37.5%, percentage of hydrogen is 12.5% and percentage of oxygen is 50%. So find out the empirical formula, and if mass of the compound is 64 gram per mole, then find out the molecular formula. So how will you convert atoms which are mentioned in the question? Atom. And next, percentage composition. Write down each percentage composition into the gram in gram unit and calculate the number of moles, small m, W by molar mass, and convert this number of moles into simplest form. And this simplest form is called empirical formula. We discussed previously. So in question, what we have a carbon atom, hydrogen atom and oxygen atom. And what is the amount of carbon is 37.5. Write this percentage form into the gram. So this is the gram. And the weight of hydrogen is 12.5 gram. And the weight of oxygen is 50 gram. So convert this into the number of moles, small m. So what is number of moles? Number of moles is the given mass by molar mass. So here, what is given? Given mass of carbon is 37.5. 37.5, and the molar mass of carbon is what? 12 gram per mole. And here for hydrogen, molar mass is 1, and what is the molar mass of oxygen is 16 gram per mole. So when we calculate this, answer is 3.125. Here 12.5 and here 3.125. So To convert this into the simplest form, you need to divide it into the smallest unit, which is 3.125. So divide this into it. 3.125 by 3.125, 12.5 by 3.125 equal to 3.125 by 3.125. Here. So here 1, here 4, here 1. So by dividing, we can get the ratio of carbon, hydrogen, oxygen is 1 So the empirical formula we can write is CH4O. Here, write it down in your notes. Here we calculate the number of moles, and this number of moles you have to convert it into the simplest form, which you all have to divide it into the smallest unit, which are the result from the number of moles. Clear? So by this ratio, means simplest ratio 1:4:1, you can write the empirical formula is CH4O. Clear? Understood, guys? So next, let's going to convert the empirical formula into the molecular formula. To convert the empirical formula into the molecular formula, we have equation that the molar mass of the compound is equal to 64 gram per mole. So write down note. One note is that small n equal to molar mass of the compound by empirical mass. So to convert empirical formula to the molecular formula, you need to calculate this small n, where the formula is molar mass of the compound divided by empirical mass. So let's going to calculate the empirical mass. Therefore, empirical mass of CH4O equal to 12 plus 4 into 1 plus 16 equal to 32 gram per mole. Therefore, small n equal to 64 gram per mole by 32 gram per mole. So let's cancel out this, and the value is 2. Clear? So next, we can calculate the molecular formula. So molecular formula equal to n into empirical formula. So the value of n is 2 and the empirical formula is CH4O. So from this, the molecular formula is C2H8O2, and this is the required molecular formula which are given in question, which so these are the So this is the formula of molecular formula, which conditions are given in the question. So when we calculate this 2 into 12 plus 8 into 1 plus 2 into 16, we get 64, means confirmed molecular formula for the question. Okay, understood? Note it down in your copy, otherwise you will forget it. So next NCERT question number 1.3, where determine the empirical formula of an oxide of iron which has 69.9% iron and 30.1% oxygen by mass. So calculate this. First try it once, then after that you see the black. First you need first you have to calculate First you have to calculate by own. After that you see the board. So here atoms, percentage composition in gram. Next, number of moles, so the given mass per molar mass. After that, simplest formula. Atom is iron and oxygen. Weight of iron is 69.9 gram and oxygen is 30.1 gram. Convert this into the number of moles. The given mass of iron is 69.9 and the molar mass of iron is 55.84 and 30.160. Answer is 1.25. Here is 1.88. So which one is the smallest unit is 1.25. So divide these two by 1.25. 1.25 by 1.25. Here 1.88 by 1.25. Answer is 1. Here is 1.5. So the ratio of iron and oxygen is 1:1.5. Convert this 1.5 into 3/2. Clear? So here 1.5 means 15/10. We can cancel out by 5. 2/3 means 3/2. Sorry, 3/2. Place this 3/2 into here. Yeah. So by multiplying both sides, we have 2:3. Clear? So what is the empirical formula is Fe2O3. That's it. Clear? So the final empirical formula for iron oxide is Fe2O3. Here, for atom is iron and oxygen. Percentage composition into gram is 69.9 gram and 30.1 gram. So the number of moles formula is given mass by molar mass. So this is the molar mass of iron and this is the molar mass of oxygen and this is the given mass of iron and oxygen. So by dividing this, answer is 1.25 and 1.88. So to convert this into the simplest unit, you need to divide into the simplest unit. So divide this 1.25 into 1.25 by and answer is 1, and also 1.88 by 1.25, answer is 1.5. So this 1.5 converted into this fractional form 3 by 2, and by multiplying this 2 we can by multiplying this fraction into 2 we have 2 is to 3. So the simplest formula is